This is a small experiment based on a property of water. The property is that if we increase the pressure on water, its freezing point drops. That means suppose it freezes at 0 degrees Celsius under normal conditions. But now if I increase the pressure, then it will freeze at some temperature below 0 degrees Celsius. Although my aim of the experiment is different. As per my thought experiment, suppose the water that I take freezes under normal conditions at 0 degrees Celsius. Now if I increase the pressure on this water, then suppose its new freezing point drops to minus 10 degrees Celsius. Now let's consider that at this moment I am at some temperature between the 0 degrees Celsius and minus 10 degrees Celsius. Like minus 5 or minus 4 or minus 7, any temperature between this minus 10 or 0 degrees Celsius. Then at this moment, if I suddenly decrease the pressure, then its freezing point will again go up to 0 degrees Celsius. And so at this moment, the water is at a supercooled state. Now what is supercooled state? Actually see, at this moment, the water is still in its liquid form at a temperature below its freezing point. And at this state, even a slight disturbance will lead to instant freeze of this water. So let's see whether my thought experiment works or not. So here is some water, and I have taken this in this bottle, and this is the valve. Through it I can increase the pressure inside. Now you might ask me one thing, why so less amount of water? Well, the reason is that water has a very high seismic heat capacity. This means that even a small amount of water will take in or release a considerable amount of energy for unit change in temperature. And so of course I don't want to wait for hours for this experiment, so I am taking this much water. Now before this experiment, we have to conduct another small experiment first. The experiment is about after how much time will this water or this amount of water freeze under normal conditions. Now you might ask me that why is this information so important? Well, let's take an example. Suppose I have some amount of water and it is under normal conditions and it freezes in 30 minutes. That means this amount of water reaches its freezing point in 30 minutes. Now let's consider the pressurized case. Under the pressurized case, the water will not freeze within 30 minutes. This is because the freezing point has dropped. But it's true that its temperature will reach the original freezing point, I mean the freezing point under the normal condition, in 30 minutes, right? Now as I said that I want a temperature between the original freezing point and the new freezing point. So if I know that the original freezing point is achieved in 30 minutes, then I can take out the bottle in like 33 or 35 minutes. That means at this time, 33 or 32 or 35 minutes, the water will be at a temperature below its original freezing point but above its new freezing point. That's why this information is very important. So here's the data collector or graph or whatever you say for the primary experiment. I've taken a 5-minute accuracy interval. I mean, I'll be checking the state of water after every 5 minutes. Now I can take time longer than this, like 10 minutes or 20 minutes, or even smaller than this, like 1 minute or 1 second also. But 1 minute and 1 second is quite inconvenient, right? But it's true that the less time I take, the greater is the accuracy. Now a very important thing to note, that this data is variable. I mean the time interval or the time after which the water reaches its original freezing point, this time will be variable actually. This is because it does depend upon the initial temperature of water, and temperature of water at different times of the day is different. This is because I am using tap water and the outside temperature does influence tap water. You see, this graph actually represents the variation of outside temperature with time. In the morning, see, this temperature is less, and in the evening or after evening, the temperature is less. But during the noon or at afternoon, the temperature is maximum. and I am doing this experiment at afternoon only. So the time that I am going to get now will be different from the time that we'll get if I did this experiment in the morning or at midnight. So whatever, let's conduct this experiment. So I did the experiment, and my observation is that that amount of water freezes in 50 minutes. Now as this is a 5-minute accuracy, so there will be an error. So I will be considering sometime before it, like 48 or 49 minutes as the time when the water reaches its freezing point. So in the original experiment, I'll be waiting for like 50 minutes or more than 48 or 49 minutes so that I can get a temperature between original freezing point, I mean freezing point under normal conditions, and the new freezing point. So let's pressurize the water inside the bottle and put it in the refrigerator. Here, after 50 minutes, I have taken out the bottle, and now I am going to open the cap. Now as per my thought experiment, as the pressure drops, the freezing point should rise, and now the temperature of the bottle is in between the new freezing point and the original freezing point, so it will be in a supercooled state, and with slight disturbance it should freeze. Now as I open the bottle, I will disturb it intentionally to a greater extent to enhance the process of instant freeze. So let's see this works or not. So it does work, and my third experiment is right. So that means we can achieve the supercooled state by this process also.